In the silent stretches between the stars, most things are still, ancient and unremarkable. But even here, in this profound emptiness, something moves, something that does not belong. Its journey began far beyond our solar system, traveling across unimaginable distances, through cold darkness and across centuries of cosmic time. This traveler is known as 3I Atlas. At first it seems insignificant, a mere pinprick of light against the infinite void. Yet even the smallest glimmer in space can carry stories far larger than the mind can imagine. For this interstellar visitor, what appears small from afar may contain mysteries beyond anything our instruments have yet witnessed. 3I Atlas drifts silently toward the orbit of Mars, a faint halo of light surrounding a darker core. Dust and subtle traces of gas trail behind it, nearly imperceptible against the cosmic backdrop, yet hinting at hidden processes within. It is not like the comets we know, born of the sun's warmth and the familiar materials of our solar system. It is a traveler from another star, a wanderer that has never known our sun. And yet here it drifts, approaching the red planet with a quiet inevitability that captivates both imagination and curiosity. Consider the enormity of its journey. Billions of years across the void, through cold darkness, past distant stars untouched by solar heat, carrying with it the chemical signatures and silent histories of worlds far beyond our reach. Imagine what secrets it might hold, what stories of planetary systems, of suns long extinguished, or of other travelers that have crossed its path. Each fragment of its existence is a fragment of a universe far older and vaster than the one we inhabit. Through the lenses of the ExoMars Trace Gas Orbiter and Mars Express, we are granted a rare glimpse of this traveler. Billions of kilometers away, its presence feels almost tangible, intimate even, as if the cosmos itself has drawn back the curtain to reveal a fleeting mystery. The faint nucleus, hidden within a halo of dust and gas, pulses with subtle changes, suggesting internal dynamics that challenge our understanding of interstellar bodies. Its path is unlike any object born within our solar system. It moves not in a predictable orbit but along a hyperbolic trajectory, shaped by forces older than human history. It glides through the solar system with a motion that whispers of countless millennia, spent wandering the darkness between stars. Its journey is both solitary and enduring, a time capsule of the cosmos, preserved in motion and mystery. The faint nucleus, barely discernible within its glowing envelope, conceals secrets that may never be fully known. Its surface, shrouded in dust and ice, hints at processes and structures unlike any comet observed before. There is a quiet tension in its motion, a subtle suggestion that what we see is only part of a much greater story, one that stretches far beyond Mars, far beyond our solar system. As it draws closer, the comet's presence begins to feel more immediate. It is small, almost unnoticeable against the vastness of space, yet it evokes a profound sense of awe. The silence of the void, the cold emptiness, and the slow, deliberate passage of this object together create a feeling that is both humbling and unsettling. This is not merely a wandering comet. It is a messenger from another part of the galaxy, a visitor that challenges our perception of the familiar and the distant. In observing 3I Atlas, we confront the extraordinary in the ordinary. A tiny glimmer, moving silently, becomes a window into the vast unknown. The questions it raises are as important as the answers we seek. Why is it here? What has it seen on its journey? And ultimately, is this visitor truly a comet, or something far more enigmatic, quietly threading its way through the silent corridors of space? ESA's orbiters and NASA's rovers, instruments of human curiosity and ingenuity, turned their gaze toward the distant visitor. Silent sentinels in orbit and on the Martian surface, they observed without interruption, recording data in precise detail, their lenses and sensors capturing glimpses of a traveler that had never encountered our world before. Each image, each measurement was a thread of understanding, woven carefully across billions of kilometers of space, connecting us to a visitor from another star system. From the high vantage of orbit, the ExoMars Trace Gas Orbiter scanned the region, its instruments attuned to the faintest hints of light, the slightest shifts in motion. Alongside it, Mars Express silently captured frames of dust and ice, translating their subtle glow into images that would soon stir both wonder and curiosity. The rovers below, though constrained by their terrestrial environment, monitored the Martian skies for any change in brightness or shadow. The daily rhythms of the planet now intersected by the silent approach of 3I Atlas. The data streaming back from these machines painted a portrait of a comet unlike any other. Its faint coma, a diffuse halo of gas and dust, revealed irregularities in shape and density. Sensors detected subtle fluctuations, variations in light scattering, hints that the structure of the object might not conform to known cometary patterns. Scientists noted these anomalies carefully, recording each observation with clinical precision, while the quiet hum of the orbiter's systems filled the void between Mars and the approaching interstellar wanderer. As the comet edged closer, calculations of its trajectory revealed something unexpected. Its path, though consistent with a hyperbolic orbit, exhibited minute deviations, small, almost imperceptible shifts that raised questions about its nature. Was it influenced by forces unknown, shaped by a composition unlike any comet previously studied? Each adjustment, each observation, was logged meticulously, a testament to the careful diligence of human exploration, yet hinting at a deeper mystery that refused easy explanation. The orbiters captured images of faint jets streaming from the comet's surface, their intensity varying across time, sometimes pulsing, sometimes waning. Instruments sensitive to light and temperature noted irregular emissions, not entirely explained by solar heating at this distance. The rovers, though unable to detect the object directly, recorded subtle changes in the Martian atmosphere and illumination patterns, as if the very presence of 3I Atlas cast a quiet influence across the landscape. Every measurement seemed to deepen the enigma. While the object approached Mars, the variations in brightness and structure became more pronounced. The coma's asymmetry suggested uneven outgassing, or perhaps more complex surface features than the smooth, icy nuclei typical of known comets. Scientists debated, ran simulations, and cross-referenced data, but the answers remained elusive. The more closely humanity observed, the more the comet defied expectation. In these moments of observation, the silent machinery of exploration revealed its unique role: to record, to measure, and to connect a distant alien traveler with the minds of Earth. Each image was a window, each spectral reading a whisper of understanding, yet all of it carried an undercurrent of unease. Something about 3I Atlas did not entirely fit into the frameworks we had developed over decades of observing comets and asteroids. And so, as the days passed and the comet edged ever closer to Mars, a quiet tension settled over the mission control rooms. The patterns were subtle but persistent. Tiny variations in trajectory, anomalies in emission, faint hints of structure in the coma. Each piece of data suggested that 3I Atlas was more than a simple icy wanderer. It carried with it a story, silent yet insistent, and humanity, through its instruments and intellect, was beginning to perceive its outline. In the silence of space, Mars itself became an observer, a backdrop against which the visitor's journey could be studied. And as the comet continued its slow approach, tracing a path shaped by forces both familiar and unknown, the question lingered in the minds of those watching. What truly lies at the heart of this interstellar traveler, and why does its behavior refuse to align neatly with what we know? The first high-resolution images arrived quietly, as if carried across the void by the very light that illuminated 3I Atlas itself. Through the lenses of Mars orbiters, the distant traveler transformed from a faint pinprick of light into a discernible presence, a subtle sphere surrounded by a diffuse halo of dust and gas. The visuals were not immediate revelations, but gentle invitations, coaxing the viewer to linger, to examine the delicate patterns that danced around its nucleus. Even in these first frames, the comet appeared almost alive, its faint glow shifting ever so slightly, as though responding to forces unseen and untold. The coma, that luminous envelope of gas and dust, spread outward like a whisper of the object's inner workings. In some images, the light scattered unevenly, revealing subtle variations in density. Tiny jets of material traced faint arcs across the darkness, hinting at dynamic processes far removed from the quiet of its interstellar journey. The surface remained largely concealed, veiled beneath layers of frost and dust, yet the interplay of shadow and light suggested a complexity unexpected in an object so small and so distant. Each frame invited speculation. Was the nucleus a simple icy core, as with the comets of our own solar system, or did it hide structures more elaborate, sculpted over billions of years by cosmic forces beyond human comprehension? The images teased the imagination, offering glimpses without answers, showing what was present but withholding what mattered most. The very act of observation seemed to awaken the mystery, as though humanity's gaze stirred the ancient traveler into revealing just enough to intrigue, yet never enough to fully disclose. Subtle gradients of green and pale blue glimmered in the scattered dust, caught in the faint sunlight that still reached this distant wanderer. The orbiter's instruments measured the light with precise calibration, capturing the intensity and wavelength of each photon, translating them into patterns that could be studied, analyzed, and compared. Yet, even as science attempted to quantify and explain, the images retained an aura of ambiguity, a quiet insistence that there was more than met the eye. The arrangement of the dust within the coma suggested motion, currents of material ejected unevenly, perhaps influenced by rotation or by the uneven sublimation of ices within the nucleus. Tiny streaks hinted at transient jets, their orientation and intensity shifting from frame to frame. These details were subtle, easily overlooked without careful attention, yet they marked a departure from what would be expected in a standard comet of similar size and composition. Here, in the muted glow and the faint transient structures, 3I Atlas revealed a signature of individuality, a pattern shaped by a history that began far beyond our solar system. Analyses of the images revealed further anomalies. The brightness of the coma did not decrease evenly with distance from the nucleus, suggesting regions of concentrated outgassing. Shadows hinted at protrusions or irregularities on the surface, giving the sense that the object was not a uniform sphere but a body with features sculpted by processes ancient and alien. Even the faintest hints of texture captured in pixels and photon counts became portals into a story billions of years in the making. Yet, there was restraint in the revelation. The orbiters could not expose the core fully. The nucleus remained obscured, wrapped in a cloak of dust and gas, enigmatic in its silence. Each measurement, each image was an invitation to wonder rather than a solution to the puzzle. The observer became the participant in a delicate dance of perception, balancing on the edge between knowledge and mystery, certainty and curiosity. Scientists studying these images approached them with reverence and meticulous care. Each detail, each gradient of light and shadow was examined against models of comet behavior. Comparisons were drawn with familiar comets from our own solar system, yet differences became apparent almost immediately. The irregularity of jets, the uneven distribution of material, the subtle hint of a color not typically present, all pointed toward a history and composition unlike anything commonly observed. The images also prompted questions about the formation and evolution of interstellar objects. How had 3I Atlas endured its long journey through the cold, dark reaches of space? What processes had sculpted its surface, shaped its coma, and influenced the patterns of its outgassing? Each pixel carried potential answers, yet also reinforced the limits of what could be known from a distance of millions of kilometers. The silent cosmos offered its hints but withheld the full narrative, leaving the mind to wonder, to imagine, and to speculate. Even as the images were shared with the scientific community and the public, they carried an emotional weight. There was a sense of intimacy in witnessing something that had traveled across the galaxy, now revealing its presence so quietly, yet so insistently. The comet's slow approach, the soft glow, the faint trails of dust, they all evoked a sense of participation in a cosmic event, a reminder of the scale and vastness of the universe and of the smallness of our place within it. In these first images, 3I Atlas remained elusive, its nucleus hidden, its true form unconfirmed. Yet the evidence of activity, the complexity of the coma, and the subtle hints of structure suggested that this was no ordinary comet. It was a traveler with history, a vessel shaped by processes and environments far beyond our experience. And as scientists pored over each frame, measuring, comparing, and hypothesizing, one question persisted above all others. What secrets are hidden within its nucleus, and what story has it carried across the stars? Observations of 3I Atlas revealed something astonishing. Even at vast distances from the Sun, far beyond the warmth that typically drives cometary activity, this interstellar visitor was releasing water vapor into the void. The instruments aboard Mars orbiters recorded subtle yet persistent outgassing, faint streams of molecules drifting into space, almost imperceptible against the darkness, yet unmistakably present. For scientists accustomed to comets becoming active only as they near our Sun, this was an anomaly, a puzzle that hinted at processes unfamiliar and intriguing. The detection of water began with spectral measurements. Specialized instruments captured the absorption lines of hydroxyl and water molecules, translating them into data that could be quantified. Each reading confirmed the presence of water vapor emanating from the nucleus despite its position in the cold reaches of the solar system. Normally, comets rely on solar heating to sublimate ice into gas, creating the characteristic coma and tail. Here, however, 3I Atlas defied expectation, exhibiting activity in an environment far too cold for ordinary sublimation. Researchers began to analyze possible mechanisms. Some proposed that the comet's composition included volatile compounds, substances that could vaporize at much lower temperatures than water ice alone. These ices might have been preserved over billions of years, insulated by dust layers, suddenly exposed in pockets that allowed localized sublimation. Others suggested that internal heat from radioactive decay or exothermic chemical reactions could drive the release, tiny sources of energy sustained over immense timescales. Each hypothesis was measured carefully, weighed against data, yet none fully accounted for the extent and consistency of the observed activity. Visualizations from Mars orbiters captured the faint plumes of water vapor, trailing from the nucleus like whispers of life in the cold void. The streams were uneven, pulsating gently, indicating that the outgassing was not uniform. Some areas of the surface appeared more active than others, while shadows in regions obscured by dust seemed inert. The contrast created an almost cinematic effect, as if the comet itself were breathing subtly, each exhalation reaching across millions of kilometers of space. The behavior of 3I Atlas challenged preconceived notions of cometary physics. Comets in our solar system follow predictable patterns, their activity largely dictated by proximity to the Sun. Here, however, the interstellar visitor acted independently of solar influence. Its water release suggested a history and composition shaped under conditions entirely alien to our observations. What internal processes could allow an object to expel water in deep space with temperatures approaching absolute zero? Scientists contemplated this quietly, balancing the rigor of data with the wonder of the unknown. As the water vapor spread, it interacted with sunlight and surrounding dust, creating subtle glows and transient halos. These interactions were captured by the orbiter's sensitive cameras, rendering the invisible almost tangible. In the cold stillness, the faint haze seemed to pulse with hidden energy, a gentle reminder that even in the emptiness of space, movement and change persisted. The images, though delicate, conveyed a sense of activity and presence, as if the comet were communicating through its very behavior. The scientific teams worked methodically, modeling the comet's activity to understand the potential sources. They considered the implications of this persistent outgassing for the comet's structure, a nucleus porous and layered, containing pockets of trapped volatiles, or perhaps fractured in ways that allowed localized release. Each simulation suggested possibilities, yet the reality remained elusive. The phenomenon persisted, subtle yet undeniable, leaving observers with more questions than answers. This discovery also posed larger questions about the nature of interstellar objects. If 3I Atlas could retain water and release it at such a distance, what did that imply about the conditions of its formation? Could it have originated in a planetary system rich in ices, preserved in isolation for billions of years before entering our solar neighborhood? The very act of detecting water in the void, hinted at environments far more varied than previously imagined, challenging assumptions about the universality of cometary behavior. As data accumulated, the unease of uncertainty settled in. Unlike comets familiar to humanity, this object did not behave predictably. Each measurement reinforced the mystery: water where none should exist, activity without apparent heat, behavior that defied the models derived from centuries of observation. And yet, there was beauty in this enigma, a reminder of the cosmos' capacity to surprise, to reveal the unexpected, and to humble even the most meticulous observer. Even as the orbiters continued to track 3I Atlas, the faint streams of water drifted silently, merging with the emptiness around Mars. They were a signal of something ancient and enduring, a tangible expression of a journey across light years of cold, dark space. And though the mechanisms behind this release remained uncertain, the observation itself stood as evidence of an interstellar traveler that was alive with subtle activity, defying categorization and prompting contemplation. In the stillness of observation, scientists and observers alike were left with quiet unease. How could such an object exist behaving as it did, far from any heat source in a region where water should remain frozen and inert? The mystery lingered, unspoken yet palpable, a reminder that the cosmos does not yield its secrets easily. And as 3I Atlas continued its journey, silently exhaling traces of water into the void, the question persisted: what hidden forces, what ancient processes, allowed this interstellar visitor to leak life's most vital compound where none should survive? A faint ethereal glow began to emerge around 3I Atlas, subtle at first, barely perceptible against the blackness of space, yet undeniable in its presence. The light carried a peculiar green tint, delicate and almost otherworldly, shifting gently as the comet drifted closer to Mars. Through the instruments aboard orbiters, this luminescence became more apparent, revealing a halo that seemed to pulse with a quiet rhythm, as if the comet were exhaling not just dust and gas, but light itself. It was a display both scientific and poetic, an interstellar beacon quietly asserting its existence across millions of kilometers. The green color captured the attention of researchers immediately. Comets in our solar system can emit hues caused by various compounds, but the intensity and consistency of this green glow were unusual. Scientists proposed that diatomic carbon, a simple molecule known to fluoresce under solar radiation, might be responsible. When excited by sunlight, these molecules emit light in a spectrum that appears distinctly green to sensitive instruments. Yet while diatomic carbon could explain the hue, it could not entirely account for the brightness or the uniformity observed around 3I Atlas. Images revealed more than color alone. The green luminescence outlined the shape of the coma, tracing faint wisps and filaments of gas that extended into space like delicate brushstrokes on a dark canvas. Shadows and denser regions of dust created contrast, giving the glow a three-dimensional quality, as if one could peer into the comet's atmosphere and see currents of energy flowing unseen. The effect was hypnotic, cinematic in nature, inviting the observer to linger on the smallest details: the arcs of gas, the subtle variances in intensity, the way the light bent around structures within the coma. Spectroscopic analysis confirmed the presence of multiple molecular species, not solely diatomic carbon. Cyanogen, another molecule known to fluoresce green, was detected in faint amounts. Together with other trace compounds, these molecules created a complex pattern of emission that contributed to the overall hue. The combination suggested a chemical richness beyond what might be expected in a simple comet, hinting at processes that had shaped the object long before it ever entered our solar system. Yet the more researchers studied the glow, the more questions emerged. Its brightness, the smoothness of the emission, and the way it seemed to respond subtly to sunlight did not perfectly align with known models of cometary activity. Was this simply an unusually active comet with a high concentration of fluorescent molecules, or was there something more at play? Each frame, each spectrum, suggested complexity, a subtle deviation from expectation that quietly hinted at the possibility of an unknown process. The visual impact was undeniable. Against the backdrop of the Martian sky and the star-speckled void beyond, The green glow gave 3I Atlas a presence that transcended scale. It was both small and immense, distant yet immediate, a reminder that even the faintest objects could carry remarkable signatures. Observers described it as luminous yet ephemeral, a kind of cosmic whisper that teased the boundary between natural processes and the extraordinary. As the comet drifted past Mars, the glow seemed to interact with the dust in subtle ways. Streams of material caught in sunlight glimmered more vividly, while denser regions absorbed light, creating a dynamic interplay of shadows and illumination. The effect was almost painterly, as though the universe itself had chosen this moment to display a fragment of its artistry. And in the midst of this visual poetry, the scientific questions persisted. Why was the glow so pronounced, and what did it reveal about the comet's internal composition? Researchers considered rotational effects as a possible explanation. If the comet were spinning, the orientation of jets and outgassing streams could modulate the emission of light, creating variations that enhanced the glow. Observations suggested subtle rotation, though the precise rate remained uncertain. Combined with uneven outgassing, these motions could contribute to the pulsing, ethereal nature of the light. Yet even accounting for these factors, the uniformity and intensity of the green hue remained striking, prompting deeper curiosity. There was a quiet sense of wonder among scientists and observers alike. Here was an object that had traveled across interstellar space for billions of years, yet it now revealed itself with a display that was at once visually captivating and scientifically puzzling. The green glow was a statement of presence, a signature of existence that both illuminated and obscured, revealing chemical secrets while leaving the heart of the comet, the nucleus, shrouded in mystery. And so, as 3I Atlas continued its journey, drifting through the solar system with gentle, almost deliberate grace, the question lingered. Was this luminescence merely a natural consequence of chemistry and sunlight? Or could it indicate something more, something beyond our current understanding? The comet glowed quietly in the darkness, and in its light, the universe seemed to whisper possibilities yet unimagined. 3I Atlas moves through space in a way that immediately sets it apart from the familiar bodies of our solar system. Its trajectory is not a gentle ellipse, nor a predictable orbit around the sun, but a sweeping hyperbola, curving through the cosmic landscape with a speed and angle that hint at origins far beyond our neighborhood. From the careful measurements of Mars orbiters, astronomers reconstructed its path, tracing the delicate arc across the solar system, each data point revealing a motion that defies conventional understanding. Unlike asteroids or comets born here, bound by gravity to our sun, this interstellar visitor carries the signature of a journey shaped by distant stars, long before it ever approached Mars. Its velocity alone tells a story of extraordinary travel. Calculations indicate that 3I Atlas moves faster than typical solar system comets, traveling at tens of kilometers per second, enough to escape the sun's gravitational pull without any assistance. In this speed is written a history, billions of years of solitary motion, weaving through the dark expanses between stars, untouched by planetary systems until now. It is a messenger from beyond, and every calculation of its path confirms the impossibility of its origin here, within the familiar confines of our cosmic neighborhood. The shape of its trajectory is equally compelling. The hyperbolic curve does not merely indicate a high-speed passage, it reveals a freedom from solar capture, a journey that will carry it in and then out of the solar system, never to return. Unlike objects that circle the sun for millennia, this visitor will pass through once silently, leaving behind only fleeting traces of dust, gas, and perhaps questions that humanity may never fully answer. Its path challenges our assumptions about how interstellar objects interact with planetary systems and forces a reconsideration of what is possible within the gravitational ballet of our solar system. Careful plotting of its orbit reveals subtle irregularities, deviations too small to be easily explained yet persistent enough to draw attention. Scientists pondered whether these were artifacts of measurement, the result of outgassing, or hints at internal structure influencing its motion. Even minor jets of gas, expelled unevenly from the surface, could exert tiny forces over millions of kilometers, nudging the comet along a slightly altered path. Each anomaly, though subtle, adds layers of intrigue to an already exceptional object, emphasizing that 3I Atlas is not simply passing through, but interacting with the solar system in ways that are almost imperceptible yet scientifically profound. Its hyperbolic orbit also points to an origin story that stretches across the galaxy. Unlike comets and asteroids that form from the familiar dust and ice of our Sun's protoplanetary disk, this object was born in a distant stellar nursery, shaped by conditions unknown, sculpted by forces alien to our experience. It has traveled light years, perhaps across multiple star systems, before entering our own. The realization is humbling. Billions of years of solitary motion, uninterrupted by planets or suns, culminating in this brief, observable passage near Mars. Astronomers compared its orbit to other known interstellar visitors, such as Oumuamua and 2I Borisov. While similarities exist, high-velocity, hyperbolic paths, fleeting visits, 3I Atlas exhibits nuances that make it distinct. Its trajectory is steeper, its approach more direct, suggesting a different gravitational history or perhaps a different origin environment. Each comparison highlights the diversity of interstellar objects, revealing that our solar system is but a waypoint in a vast cosmic network, where travelers like 3I Atlas are rare but not singular. The interplay of observation and calculation builds a quiet tension. Each orbital element, inclination, eccentricity, perihelion distance, is measured with precision, yet together they hint at something beyond prediction. Scientists watch carefully as the object nears Mars, noting changes in velocity and trajectory, aware that even minute forces could alter its path. Unlike the predictable bodies we have studied for centuries, 3I Atlas reminds us that the universe is governed by rules we can approximate but never fully anticipate. Its future path remains uncertain in small, yet significant ways. Though its general hyperbolic route is clear, the exact details of its exit from the solar system depend on countless subtle factors: the pressure of solar radiation, the distribution of outgassed material, perhaps even unseen forces that have yet to be identified. The comet is a living puzzle, its motion a dialogue between natural law and the unknown, speaking to observers in a language both precise and mysterious. Amid these calculations, the object retains an almost poetic quality. It is a traveler, moving silently through the solar system, indifferent to human observation, yet offering glimpses into processes far beyond our comprehension. The hyperbolic arc is not merely mathematics. It is a record of cosmic history, a path etched across space and time that invites reflection on scale, movement, and the extraordinary rarity of witnessing such a journey. And as 3I Atlas continues, moving steadily along its hyperbolic curve, the quiet tension remains. Each measurement confirms its interstellar origin, yet each subtle anomaly reminds us of our limited understanding. Its path will carry it forever away from the sun, yet in the brief window of observation, it has already reshaped our awareness of what is possible. The question lingers gently in the air. What unseen forces have guided this visitor across the galaxy, and what mysteries will it carry as it disappears once more into the vast emptiness from which it came? Before 3I Atlas, there were only two known visitors from beyond our solar system. Oumuamua came first, a silent traveler detected in 2017, tumbling through space with no coma, no tail, and a shape that defied classification. Then came 2I Borisov, a more familiar-looking comet discovered in 2019, its activity consistent with icy bodies born of distant suns. And now, years later, 3I Atlas drifts through our skies carrying both familiarity and mystery, part comet, part enigma. These three objects form a fragile thread connecting our solar system to the greater galaxy. Each one arrived without warning, moved too quickly to study in depth, and departed forever. Yet each reshaped our understanding of what lies between the stars. When Oumuamua first appeared, astronomers had no frame of reference. Its light curve hinted at an object shaped like a cigar, perhaps a flattened disk, something unlike any asteroid or comet ever seen. It reflected sunlight irregularly, spun chaotically, and most curiously, accelerated as it left the solar system, as though something invisible was pushing it. No tail of gas, no visible outgassing, just motion, quiet, persistent, and unexplained. 2 years later, 2I Borisov arrived, a contrast so sharp it felt intentional. Unlike Oumuamua's eerie silence, Borisov announced itself with brightness, shedding gas and dust in classic cometary fashion. Spectra revealed familiar compounds: water, carbon monoxide, and cyanides, the same elements seen in comets born from our own sun's debris. If Oumuamua was a riddle, Borisov was reassurance, proof that some interstellar objects follow the rules we know. But then came 3I Atlas, and once again the line between the familiar and the extraordinary began to blur. At first it resembled Borisov, a cometary body with a visible coma and faint tail, yet its behavior quickly began to defy expectations. It leaked water at distances where no solar heating should have occurred. It emitted light with a strange green luminescence, unlike the flickering blues and whites typical of cometary activity, and its trajectory, though hyperbolic like the others, showed tiny perturbations that could not easily be explained by simple outgassing or radiation pressure. Each of these interstellar visitors tells a different story about the places they came from. Oumuamua may have formed in the debris of a shattered world, a fragment thrown into the void by gravitational violence. Borisov might have originated in a cold, stable planetary nursery orbiting another star, a mirror of our own beginnings. And 3I Atlas. Perhaps it comes from somewhere older, somewhere stranger, a system whose chemistry and history have left it carrying secrets that no comet before it has revealed. For astronomers, comparing the three is like piecing together fragments of a cosmic puzzle. Oumuamua teaches us about the diversity of interstellar solids. Borisov shows us that planetary systems elsewhere form familiar materials. But 3I Atlas challenges both ideas, hinting that some objects may carry with them processes or substances we have never encountered before. The fingerprints of alien environments long vanished. In scientific papers, the differences are measured in numbers: eccentricities, inclinations, reflectivities, emission lines. Yet beyond the mathematics lies something deeper, a realization that the universe is not just vast, but endlessly creative. Each visitor, in its own way, reveals that the stars are not isolated, but connected by the quiet migration of matter, fragments of one world drifting through another, frozen messengers traveling between suns long after their homes have ceased to exist. There's a certain humility in that. We often imagine the solar system as a defined place, our small island in an infinite sea. But interstellar visitors remind us that space is not empty. It is a slow, silent ocean where debris and dust and forgotten relics pass through each other's shores. The fact that we have seen 3 such objects within a single human lifetime may not be coincidence, but a sign that our instruments and our awareness are finally sensitive enough to witness what has always been happening. Still, even with this growing awareness, one question lingers. Among all 3, why does 3I Atlas feel so different? It behaves partly like Borisov, with its coma and water jets, but shines with a glow no one can fully explain. It moves with the freedom of Oumuamua, yet carries the chemical fingerprints of something distinctly unfamiliar. It is both alien and recognizable, scientific and mythic, calm and unsettling, as though 2 truths are unfolding at once. Perhaps that is what makes it unique. It sits at the boundary, between what we know and what we can only imagine, between the scientific and the sublime. And as we watch its fading green light drift past Mars, that boundary feels thinner than ever, as if, for a fleeting moment, the universe is whispering something to us. Something we don't yet understand but cannot look away from. At first, the behavior of 3I Atlas seemed predictable, the kind of gentle awakening a comet undergoes when it nears a star. But then, the numbers began to shift. Its brightness fluctuated erratically, its outgassing defied thermal models, and the direction of its tail changed without clear cause. What should have been a quiet, natural display of sunlight and ice became something far stranger, a pattern of activity that refused to align with the physics astronomers knew. Normally, when a comet approaches warmth, the ice buried beneath its surface begins to sublimate, venting gas and dust into space. The result is the familiar glowing coma, the streaming tail, the predictable dance of heat and motion. But 3I Atlas behaved as though the rules no longer applied. Even while still far from the sun, in regions where the light was too weak to melt anything, its coma began to bloom, its surface flaring with unexpected energy. The first signs of activity were recorded when the object was still between Mars and Jupiter, at temperatures far too low for water ice to evaporate. Something else was driving the release. Something hidden. The data was puzzling. Instruments showed spikes in brightness, bursts of luminosity that faded just as suddenly as they appeared. They weren't consistent with impacts nor with dust jets rotating in and out of view. Instead, they seemed to pulse, rhythmic, almost deliberate, occurring over timescales too regular to be random noise. It was as if the comet was breathing, exhaling invisible material in cycles no one could yet explain. ESA, Mars Express, and NASA, Maven, both captured faint plumes of vapor near the object, expanding outward before fading into darkness. These emissions appeared localized, emerging from only a few regions of the nucleus, rather than evenly across its surface. The result was a strange asymmetry, jets of material arcing in different directions, forming a twisted, evolving halo around the object. And within that halo, a faint green light shimmered once more, persistent, deliberate, unyielding. Spectral readings deepened the mystery. They revealed not only water and carbon compounds, but hints of something more volatile. Molecules that should have evaporated long ago if exposed to interstellar radiation during its voyage. For an object that had spent millions of years drifting between stars, the survival of such compounds seemed improbable. It was as if 3I Atlas had somehow preserved pockets of material shielded from time itself, untouched by cosmic rays, unweathered by the void. Scientists considered possibilities. Could the comet's interior structure be more complex than expected, layered like a planet's crust, insulating deeper materials? Could electrical or magnetic interactions within the coma be amplifying its emissions? One team proposed that the rotation of the object might be irregular, tumbling unpredictably, causing jets to point in varying directions as they fired. Another theory suggested that the object's composition could include unknown refractory materials that release gases not through heat, but through chemical reaction. Each hypothesis offered fragments of explanation, but none could fully reconcile the observations. The object's brightness would surge, then fall, then surge again. Not in response to sunlight, but as though triggered by some inner mechanism. Even its tail, normally a product of solar radiation pressure, behaved strangely. Instead of forming a smooth, straight ribbon of dust trailing the comet's motion, 3I Atlas's tail seemed to bend, sometimes even curving toward the sun. Such reversals are rare and usually temporary, but in this case, they persisted, evolving slowly over days. Some speculated that the interactions between the solar wind and the comet's unusual ion emissions could be creating electromagnetic effects, subtly steering the particles. Others wondered if unseen fragments or smaller bodies accompanying the comet were influencing its field, creating patterns of turbulence that distorted its visible trail. Whatever the cause, the result was mesmerizing. Through telescopes, the tail of 3I Atlas shimmered like a veil in motion, delicate, shifting, unpredictable. Its shape changed nightly, sometimes expanding, sometimes fracturing, sometimes vanishing altogether before reappearing elsewhere. It was alive with behavior, yet devoid of intention. Among scientists, a sense of quiet fascination grew. This was not just another data point, another comet to be cataloged and forgotten. It was a phenomenon in motion, something behaving as though guided by unseen hands, responding to forces that our equations had yet to name. The calmness of the data reports belied the unease underneath. The comet's light curve defied smooth modeling. Its gas ratios defied classification. Its movement through space, though steady, carried subtle deviations, like the faint tremor of a needle drawn by something just out of sight. For a brief moment, some even wondered, could the object be hollow? Could internal cavities or fractures create resonances that amplified the release of energy? Could the comet itself, an ancient traveler from the interstellar dark, be reacting not just to sunlight, but to something intrinsic, something embedded deep within it from a time before it ever met the sun. The idea lingered at the edges of discussion, unspoken yet impossible to dismiss, because the data didn't lie, and yet it didn't quite fit. As 3I Atlas continued its journey inward, scientists watched, recorded, and recalculated. Every observation seemed to produce another question. Every spike in brightness hinted at a new layer of mystery. And in the quiet between those bursts of activity, one thought began to take shape. What if 3I Atlas isn't merely reacting to the sun's energy, but to something else entirely? Something unseen, something waiting. When the first compiled data from Mars orbiters reached Earth, it moved quietly, through encrypted channels, across long distances, from one mission control to another. There was no urgency in the voices that received it, just quiet curiosity, the kind that has always defined science at its best. At the European Space Agency, analysts gathered in the dim light of the Mars Express Operations Center. A silent sequence of images filled the main screen. 3I Atlas, surrounded by a faint emerald glow, its shape blurring into the void. The room was calm. Only the soft hum of computers accompanied the faint tapping of keys as scientists compared new readings with older models. At NASA's Jet Propulsion Laboratory, the mood was similar, a mixture of patience and awe, the kind that comes when humanity realizes it's glimpsing something that might never pass this way again. On one screen, the comet's light curve. On another, spectral graphs showing molecular emissions. Beneath the data, a quiet question pulsed. Why does it behave this way? The reports were careful. Each sentence measured, every claim wrapped in caution. There were mentions of outgassing anomalies, irregular rotation, spectral lines inconsistent with common volatiles. No conclusions, only possibilities. The tone remained professional, the words neutral. Yet between them, a subtle tension, the kind that appears when science brushes against the unknown. Dr. Elena Paredes, a planetary scientist with ESA, wrote in her mission log, "The object is neither predictable nor chaotic. It follows patterns we can detect but not yet explain. It is almost responsive." Her note was buried deep in the technical summary, unseen by the public, but it captured what many in the community quietly felt, that 3I Atlas was not simply another interstellar rock passing by. It was a messenger from a realm of space where our definitions of normal may no longer apply. NASA's team cross-checked the findings. The spectral signatures showed traces of cyanogen and diatomic carbon, substances known to cause green emissions, but their ratios were unusually high. The object's brightness did not correlate with its distance from the sun, as comets typically do. Sometimes it dimmed when it should have brightened. Other times it flared without apparent reason. One analyst, reviewing the data overnight, noted how the outbursts seemed almost rhythmic, not precisely periodic, but pulsing in a way that suggested an internal rhythm. The observation was logged, debated, then carefully set aside. Too speculative, too suggestive. Science must remain cautious. Still, the curiosity persisted. Across ESA, NASA, and other observatories worldwide, conversations deepened, quiet, meticulous, and filled with wonder. The language remained technical, yet the undercurrent was unmistakable. Every new line of data carried both excitement and unease. At the European Southern Observatory, one astronomer described the feeling best. "It's like listening to an echo from another civilization's experiment, except the experiment is nature itself." The two agencies began sharing information more frequently, a collaboration born not of urgency, but of shared humility. Because 3I Atlas was teaching them something they hadn't expected, that even after decades of studying the cosmos, surprises still linger in the most familiar data. Publicly, NASA's statement was restrained. The interstellar object, 3I Atlas, exhibits unusual behavior consistent with active outgassing. Further analysis is underway. But within private meetings, words like non-gravitational acceleration and energy distribution anomaly began appearing more often. These phrases meant little to most people, but to scientists, They hinted at possibilities that stretched far beyond conventional comet dynamics. ESA's internal simulations showed small but measurable deviations in the object's path, movements not fully explained by solar pressure or outgassing forces alone. They were subtle, almost insignificant in scale, yet persistent. The data suggested that something was pushing, however faintly, against the natural drift of space. No one suggested anything extraordinary, not publicly. But the quiet tone of communication began to change. The reports carried longer pauses. The email chains grew slower, as if each scientist, upon reading a colleague's findings, had to stop, to think, to breathe, to accept that something didn't quite fit. This wasn't excitement in the usual sense. It was reverence, the kind that comes when discovery brushes against mystery. In one NASA meeting, a veteran astrophysicist leaned back in her chair after a long presentation. The room was silent. She looked at the image on the screen, the glowing green halo around a tiny fragment of ice and dust, and said softly, "It's strange how something so small can make us feel so incomplete." The others nodded. There were no arguments, no grand statements, just an awareness that the universe had once again shown them how little they truly knew. For weeks, the observations continued. Each agency tracked 3I Atlas with increasing precision. Each new reading added data, but also deepened the silence between conclusions. They were gathering knowledge, yes, but also confronting the boundary of what knowledge could reach. And in that stillness, a shared realization began to form. 3I Atlas wasn't just a scientific object. It was a mirror, a reflection of human curiosity itself, fragile, persistent, endlessly drawn toward the unknown. The chapter closes with this quiet truth. Even in the age of technology and certainty, the universe still finds ways to humble us. And as the faint green light of 3I Atlas drifts onward, the scientists who study it are left with the same feeling that humanity has always carried when looking at the stars. A quiet, trembling wonder in the face of infinite uncertainty. In the deep silence of the control rooms, the next phase of discovery unfolded, not through images or motion, but through light itself. The light from 3I Atlas had traveled millions of kilometers, a fragile stream of photons carrying the secrets of its composition. When that light reached the instruments of Mars orbiters and Earth-based telescopes, it broke apart, refracted into bands of color, dissected into patterns that spoke the language of chemistry. The spectrum appeared on the monitors like a faint, glowing fingerprint, lines of red, green, and violet dancing across the black. To most eyes, it was abstract, but to those who had spent their lives reading these patterns, it was a story, written not in words, but in the quiet shimmer of energy. The analysis began cautiously. Early scans confirmed familiar signatures: carbon, oxygen, traces of water vapor. Substances that whispered comet, fitting neatly within expectations. But as the instruments refined their focus, new patterns emerged, faint but persistent, scattered among the familiar lines. There were spectral features that didn't belong. Tiny peaks where there should be silence, missing valleys where absorption should occur. Some corresponded to exotic molecules rarely seen in natural objects. Others resisted classification altogether. At first, scientists suspected instrument error, a calibration drift perhaps, or interference from Martian dust scattering sunlight. Yet every recheck confirmed the same result. The lines were real. The chemistry was not wrong. It was unfamiliar. In a quiet lab at ESA's Mission Analysis Center, a spectral physicist named Dr. Andrei Voronov leaned over a series of graphs. He adjusted the range, zoomed in, cross-referenced with a library of known molecular bands. His brow furrowed as he whispered to himself, "It's like it's glowing from the inside." The emissions were not entirely consistent with sunlight reflecting off dust or ice. Instead, they suggested something generating energy within, faint, persistent, and rhythmic, like a pulse. At NASA's Goddard Space Flight Center, similar findings arrived independently. One of the spectrometers on Mars Reconnaissance Orbiter had detected ultraviolet signatures not typically seen in cometary comae. The readings hinted at a compound with high reactivity, something unstable, possibly synthetic. But that word, synthetic, was never written in the reports. It lingered unspoken in the pauses between discussions. Publicly, the results were shared as unusual chemical diversity. In scientific terms, that was cautious, accurate, and safe. But within the quiet halls of research facilities, conversations grew more curious, even philosophical. How could an object from the cold interstellar void, a place far beyond any star's warmth, produce such signals? Was it composed of material forged in some violent stellar nursery, long extinct? Or did it carry the chemical legacy of a world we would never see? The data continued to build. The green glow observed earlier now made more sense. Diatomic carbon, CN radicals perhaps, yet their intensity remained strangely disproportionate. Ratios between elements didn't match what models predicted. Something in its chemical makeup was amplifying the light, sustaining it far longer than normal reactions could. In one meeting, a researcher quietly said, "It's behaving less like a comet and more like a system." No one responded. They simply looked again at the spectral lines, those elegant silent signatures, and let the thought drift through the air like static. Outside the labs, telescopes across the world were tuned toward the same coordinates. In Chile, the Atacama Observatory recorded faint infrared emissions inconsistent with thermal models. In Hawaii, a team detected a whisper of radio frequency patterns buried in the background noise. Each reading was minor on its own, easy to dismiss. But together, they formed a mosaic of quiet defiance, an object that refused to be ordinary. The narration slows, letting the images breathe. A prism of color drifting across the screen, the faint hum of data streams merging with the stillness of deep space. The audience can almost see it. Photons leaving the glowing surface of 3I Atlas, traveling through the black, touching the cold lenses of human-made machines that try with fragile precision to understand. What they reveal is not just chemistry, but something deeper, a message about the limits of human comprehension. Because even when every molecule is identified, every ratio logged, and every anomaly charted, there remains something the data cannot explain. Why it glows like this and what sustains that light in the emptiness of interstellar dark. Perhaps the answers lie in its structure. Perhaps they belong to forces we have yet to measure. Or perhaps, as some quietly wonder, it carries within it a story written before our sun was born, a remnant of ancient creation, whispering through wavelengths and silence. And so the chapter fades with a slow pan across the spectral graph. Thin lines of light stretching across blackness, each one a fragment of truth. Light never lies. But sometimes, it doesn't tell the whole truth either. The question lingers, echoing softly as the scene dissolves into darkness. Is there more than meets the eye in the light of 3I Atlas? In the quiet after the data comes reflection. The graphs fade, the noise of numbers stills, and what remains is the simple, humbling awareness of distance, of scale. Beyond the instruments, beyond the laboratories and control rooms, there is a silence that no machine can measure. It is the silence of space itself, vast, unbroken, eternal. 3I Atlas drifts somewhere within that stillness, cold and distant, untouched by time as we know it. It does not know we are watching. It does not care that billions of years of evolution have led to eyes that can see it, minds that can name it, and hearts that can wonder about it. And yet, our gaze remains fixed, because that's what we do. We look into the dark, searching for reflections of ourselves. Every comet, every star, every distant signal we capture carries a strange duality. It is both a discovery of the universe and a rediscovery of our own fragility. When scientists first detected interstellar objects like Oumuamua, it wasn't just curiosity that stirred. It was something older, a quiet yearning that sits deep within the human story. A need to understand what lies beyond the horizon, even if it never answers back. There is something profoundly human in the act of looking up, at night skies filled with unreachable light, knowing that most of it has already died. And yet we still make wishes on stars. We still send machines into the dark, asking questions no one may ever hear answered. Perhaps this too is our nature, to wonder, even in futility. The images of 3i Atlas, glowing faintly green against the endless void, evoke that same quiet introspection. It is not just an object to be studied, but a mirror reflecting the mystery of existence itself. We are drawn to it not because it threatens us or because it promises revelation, but because it reminds us that we are small, and that smallness is beautiful. Think of the photons leaving its surface, traveling across space, untouched for millions of kilometers, only to meet a glass lens hovering around a planet. That meeting, that intersection of cosmic chance and human intent, is itself extraordinary. It tells us that we belong to this universe not by dominance but by curiosity. We are its observers, its storytellers, its dreamers. Perhaps that is the quiet purpose of every unknown, to remind us that not everything must be understood, that sometimes mystery itself is the gift. We seek answers, yes, but we also find meaning in the search, in the way the mind stretches towards something infinite. The unknown humbles us, softens the illusion of certainty, and teaches patience in the face of cosmic silence. And yet, behind the calm, there is a whisper of unease, a question that stirs when the lights fade and the data rests. What if what we see out there is not alien at all, but a reflection of something within us? Our longing for connection, our fear of isolation, our hope that somewhere in the dark there is order, or at least understanding. As 3i Atlas moves further into the Martian sky, its glow fades slightly, but the sense of wonder does not. It lingers, quiet and persistent, like the afterimage of a dream we can't fully remember. The narration slows, letting the silence breathe, letting viewers feel the weight of the infinite pressing gently against thought. We measure light, chart orbits, analyze spectra. And yet, beyond all that precision lies something unquantifiable: awe. The quiet awe that hums beneath every scientific discovery. It is not loud, not dramatic. It lives in the spaces between questions, in the breath before a revelation, in the humility of not knowing. Maybe the purpose of encounters like this is not to decode the universe, but to remember our place within it. To stand for a moment in the presence of something we cannot command or comprehend, and to feel peace, not fear. For all our searching, the universe never speaks loudly. It answers in silence and asks us to listen. At last, the moment arrived, the point of closest approach. 3 Atlas, the interstellar traveler, had come nearer to Mars than anyone had ever expected. From the cold emptiness of the void, it slipped silently past the orbit of the red planet, its faint coma shimmering like mist in the light of a distant sun. Every camera, every sensor, every instrument pointed toward it. For a few brief hours, all the eyes of two worlds, human and mechanical, were fixed on a single moving light. From above Mars, ESA's orbiters watched the comet glide by, its trajectory a perfect arc traced across the darkness. The data showed just how close it came, a cosmic hair's breadth by astronomical standards, though still millions of kilometers away. In that distance, however, lay intimacy. The cameras aboard the trace gas orbiter captured the glow of the coma scattering sunlight, revealing patterns too organized to ignore, faint lines and gradients that seemed to pulse. Was it merely a trick of light? Or something deeper, woven into the material of the object itself? For the scientists watching from Earth, the moment was surreal. Mars, a planet we had studied for decades, was now the stage for an encounter with something from another star. The red dust, ancient and silent, bore witness to a meeting that had never happened before in human history. A visitor from interstellar space brushing past our planetary neighbor, leaving a trail of faint green luminescence in its wake. Every frame transmitted from orbit seemed to carry whispers of detail. Jets of vapor erupted in irregular bursts, their timing unpredictable, their symmetry imperfect. In some images, the nucleus appeared to shimmer, as though light were bending subtly around it. Some scientists proposed it was a diffraction artifact. Others wondered if the surface itself was unusually smooth, reflective in ways no natural ice should be. Within hours, these frames were enhanced, cleaned, and analyzed pixel by pixel, each one a silent attempt to understand what 3I Atlas truly was. Down on the surface, Mars Reconnaissance Orbiter's high-resolution camera caught a faint green reflection glancing across the thin upper atmosphere. It was faint, just a few scattered photons captured at the edge of the image, but enough to prove that the object's luminescence was not merely optical illusion. The glow was real, radiating across empty space, carried by something unseen. The precision of these observations was staggering. Each orbit, each calibration adjustment, each corrected pixel brought humanity infinitesimally closer to truth. And yet, the closer we looked, the stranger it appeared. The tail of the comet did not behave like dust and gas alone. It twisted, folded, then realigned, as though responding to subtle variations in the solar wind, or perhaps to something else, an unseen influence, an unknown mechanism of motion. For hours, mission teams in Europe and the United States compared notes, aligned data sets, and cross-checked calculations. The numbers made sense until they didn't. Tiny shifts in brightness, irregularities in its trajectory, faint electromagnetic fluctuations recorded by Mars orbiters, all real, all measurable, but none entirely explainable. Every variable that could be controlled was. Every possibility accounted for, except the one that defied prediction. Imagine the silence then, as new images arrived, sharper, clearer, impossibly detailed. The nucleus of 3I Atlas appeared fractured, divided into subtle planes of geometry, as though its surface had been sculpted not by nature but by some hidden process. The reflections traced edges too straight to be coincidence, lines that suggested order. Perhaps it was nothing. Perhaps it was everything. Even so, the mood in mission control was not one of panic, but quiet awe. The scientists spoke softly, as though reverence were the only appropriate response to such a mystery. They knew this was history unfolding, an encounter not of confrontation but of observation. Humanity had reached a point where we could see such things with clarity, yet still stand humbled before them. The final data stream from Mars that night showed the comet moving away, a slow retreat into the black. The faint glow dimmed as it passed beyond the orbit of Mars, its tail stretching into the void, caught briefly in the last rays of reflected sunlight. No more details could be extracted. The light was fading, and the visitor was leaving. And yet, those final images lingered. Hidden within the noise, patterns emerged, repetitions, harmonics, alignments that no one could dismiss as coincidence. It was as if the universe had written something into its design, a language not yet translated, a secret kept within the ice, the dust, the glow. For now, all we could do was watch as it drifted farther from Mars, disappearing into the same silence from which it came. The data was collected, the images archived. But somewhere, deep within the structure of 3I Atlas, questions remained, quiet, patient, waiting. Perhaps it was just a comet. Perhaps not. As it vanished into the darkness, one thought echoed through the minds of all who had seen it. What if what we witnessed near Mars was not a reflection of sunlight, but a reflection of intention? The new images arrived quietly, transmitted across millions of kilometers, packets of data that would soon reshape how we thought about 3I Atlas. At first glance, the object still looked like a comet, a glowing haze, a faint tail, and a dark core surrounded by vapor. But beneath that familiar shape, something strange began to emerge. The light it reflected wasn't random. It flickered in patterns. Precise, consistent, as though the object were built to catch sunlight in a particular way. Scientists began to analyze the brightness curve, the subtle rhythm of how the object glowed as it rotated. For a natural comet, these variations are usually irregular, caused by uneven ice or tumbling motion. But 3I Atlas rotated differently. Its brightness rose and fell in smooth intervals like a pulse. A perfect repeating beat, as though some hidden geometry lay beneath the dust. High-resolution imaging revealed sharp angles in the light curve, edges where reflection abruptly shifted. It wasn't proof of anything artificial, but it was enough to make even the most cautious researchers pause. Could the surface really be that smooth? Could nature sculpt lines that clean, planes that flat, faces that seem to catch light and send it flashing back into space? In every frame, faint traces of symmetry appeared. Not perfect, but close enough to stir unease. An uneven hexagonal outline, a triangular reflection repeating every few degrees of rotation. Each anomaly dismissed, explained, then quietly reconsidered. The narration of data became careful, almost reverent. Reports described possible reflective heterogeneity. Others spoke of localized surface coherence. Scientific phrases that, beneath their restraint, hinted at something no one dared to say aloud. Structure. Still, there were natural explanations. There always are. Maybe 3I Atlas had fractured in a way that left exposed crystalline planes of ice. Maybe its rotation and solar heating caused preferential reflection. Maybe it was all coincidence, an illusion born from light and distance. Yet even so, the feeling remained that this was not the randomness of debris but the elegance of design. The object's rotation period was measured again. 7 hours, give or take. But as the data accumulated, small variations appeared as though the rotation were being adjusted, slowed, then restored, by forces not yet understood. No jets were visible to explain it. No torque from vapor release could be confirmed. The changes were real, yet originless. Infrared readings told another story. Certain regions of the surface reflected more heat than expected. Others seemed colder than space itself. A patchwork of temperature gradients that made no sense for a body warmed by sunlight, as if parts of it absorbed heat, while others rejected it. Like panels, switching on and off, without pattern or reason. By now, 3I Atlas had passed Mars, drifting deeper into the sunlight. Its glow intensified, and for a brief window the structure became clearer. The coma, the haze surrounding it, rippled, as though shaped by magnetic fields. Spectral readings hinted at charged particles behaving in organized motion. Not random turbulence, not chaos. Something directed. In the control rooms across Earth, the tone grew quiet. No one spoke of alien craft or machines. Those words remained unsaid, buried beneath scientific restraint. But in the silence between transmissions, the question lingered. What kind of object behaves like this? Rotating with precision, reflecting light and rhythm, shedding material with deliberation? The data, as always, refused to yield its truth easily. Each finding balanced on the edge between wonder and skepticism. Every new observation seemed to deepen the mystery rather than solve it. Was this how all interstellar objects behaved, and we simply hadn't noticed before? Or was 3I Atlas, in its quiet passage through our solar system, revealing something more? A pattern that didn't belong to nature alone? The final composite image from the Mars orbiters showed the nucleus in faint silhouette. Beneath the glare of reflected sunlight, shadows traced faint geometric ridges, too faint for certainty, too distinct to ignore. The scientists debated for hours, adjusting filters, reprocessing data, seeking flaws in the optics. But no matter how they cleaned the image, the shapes remained. Edges, angles, order, and as the object moved on, fading slowly into the depths of interplanetary space, it left behind a question that no equation could resolve. If what we saw was real, if those lines and planes were not tricks of light, then what was 3I Atlas really? A fragment of rock from another star? Or the echo of something older and made? From the thin edge of Mars's atmosphere, cameras turned outward, capturing a spectacle that no one had expected to see in this silent corner of the solar system. A stream of vapor arced through the void, glistening faintly in sunlight. It rose from 3I Atlas like a slow, weightless waterfall spilling into nothingness. Each particle of ice reflected the distant light of the sun, turning the darkness into a faint silver mist. And in that mist, Mars watched, silent, red, and still. The readings were unmistakable. Water. Real, measurable water, streaming from an object that was far too cold for ice to sublimate. The temperature of deep space should have frozen every molecule solid, locking it tight within rock and dust. Yet here, a cascade flowed freely, continuous, powerful, and completely unexplainable. ESA's spectrometers traced the plume's composition: H2O, molecular oxygen, traces of carbon dioxide, but in proportions that defied solar heating models. There was no energy source nearby strong enough to cause this outgassing. No solar flare, no hidden vent, no internal heat. Just a steady, rhythmic release, as though the comet were breathing. On the Martian horizon, the vapor trails shimmered against the sunlight, forming luminous curtains that stretched across the void. It looked like liquid light, cascading from nowhere, fading into the black. The scene felt less like an observation and more like a vision of physics unraveling in real time. Scientists ran simulations, desperate to make sense of the data. Perhaps micrometeorite impacts exposed volatile ice. Perhaps cosmic rays had cracked the surface, freeing hidden reserves. Perhaps it was just chance. But every model required a source of heat that wasn't there. Every equation ended in contradiction. The pressure of the escaping gas was immense, enough to alter 3I Atlas's spin by measurable degrees. And yet, the pattern of that spin didn't match the venting jets. The object was turning with precision, ignoring the very forces that should have pushed it off balance. Like a body moving by its own will, adjusting, compensating, correcting. The vapor itself carried mysteries of its own. Embedded within were particles that shimmered oddly under polarized light. Microcrystals of unknown composition, possibly metallic, possibly something else. They refracted green and violet hues as they drifted, almost alive in their motion. Each trail seemed to pulse faintly, timed with the object's slow rotation, as if linked to a heartbeat hidden beneath its shell. From the orbiters, the images appeared surreal. Arcs of vapor streaming from a single nucleus, illuminated by the distant sun, drifting across the red horizon of Mars like ghostly auroras. And as the gas spread outward, it formed tendrils that bent slightly, as though following invisible magnetic lines. It was water, yes, but it behaved like plasma. The scientists at ESA's control center stared at the spectral plots, each line whispering a different impossibility. Hydrogen emission spikes, energy signatures inconsistent with sunlight alone, wavelengths suggesting electrical excitation. In simple terms, the water seemed charged, as though it had passed through something powerful, something controlled. For days, the comet trailed this luminous waterfall through the void. It was beautiful beyond words, yet profoundly unsettling. How could a fragment of interstellar debris carry so much life-giving water and release it here in the desert sky of another world? The thought lingered. That water, the symbol of creation itself, was falling freely in a place where no life existed to see it. Mars, silent and ancient, bore witness. Its thin atmosphere barely stirred as the vapor drifted above. No wind carried it. No sound accompanied it. Only the faint hum of radio signals echoing across space as humanity watched from afar. We were seeing something that should not be possible. An object without heat, without energy, releasing the one substance most vital to life. The contradiction was total. If the outgassing wasn't caused by heat, then what force was driving it? Was there an internal reaction, chemical or otherwise? A buried mechanism perhaps responding to sunlight not as warmth but as signal? Every answer led to another question. Every test ended in silence. And yet, amid the confusion, one truth became clear. Whatever 3I Atlas was, natural or not, it was active. Deliberately, rhythmically active. Not a frozen relic drifting through space, but a body doing something, reacting, breathing. The vapor streams continued for another 48 hours before suddenly ceasing, not fading, but stopping, as if a switch had been turned off. No gradual decrease, no lingering residue, just silence. The plume vanished into the stars, leaving only data and disbelief. In the quiet that followed, one question echoed across every research station, every observatory, every human mind watching this silent spectacle unfold. If water was flowing freely from an object colder than death itself, Then what kind of engine was working inside the heart of 3I Atlas? The data poured in like whispers from another world. Every new line of code, every faint signal, brought with it more confusion than clarity. 3I Atlas had broken too many rules, left too many questions unanswered. And so, quietly, inevitably, the theories began. The first and most grounded were simple extensions of what we already knew. Some suggested 3I Atlas might be a fragment of a disrupted planet, an icy shard ejected from another solar system billions of years ago. Perhaps the strange glows and outgassing were the scars of that ancient violence, a wounded body still venting its last breath of water and gas into the dark. Others argued for more exotic but still natural causes. Maybe cosmic radiation had altered the chemistry of its surface, creating unstable compounds that released energy in sudden bursts. Maybe it carried a core rich in volatile materials, superheated from within by radioactive decay. It could be, they said, a natural reactor, not by design but by accident. A cosmic coincidence written into its composition. These ideas were elegant, reassuring in their normalcy. They gave the mystery shape without surrendering to the unknown. But beyond the quiet halls of the observatories, in forums and message boards, a different kind of speculation began to grow. One not born from equations but from wonder. The green luminescence, the rhythmic spin, the precise bursts of vapor. These were not random, some said. They were signatures, patterns too deliberate to be chance. A few researchers, speaking cautiously and always off record, admitted the data could not yet rule out non-natural explanations. It was enough to ignite 1,000 imaginations. The idea spread, not as panic but as fascination. What if 3I Atlas was not just an interstellar traveler, but a creation? A probe, perhaps, drifting between stars for reasons long forgotten, or a remnant of something ancient, sent adrift by a civilization that vanished before Earth had cooled. It was easy to dismiss such thoughts. Science demands restraint, evidence, and patience, all of which this mystery refused to provide. Yet, late at night, when the data screens dimmed and the chatter of analysis fell silent, even the most disciplined minds found themselves wondering if someone, somewhere, had built it. What would they have been searching for? And then came the counter-arguments, firm and clear. We have seen this before, they said. We have. When Oumuamua passed through, its acceleration sparked the same questions, and in time, explanations emerged. Radiation pressure, outgassing, geometry, all complex, but natural. Maybe 3I Atlas was no different. Maybe the universe was simply better at surprising us than we were at understanding it. But even those explanations carried unease. Each answer required another exception, another stretch of what we believed nature could do. Every possibility seemed to defy its own logic. Was it truly coincidence? Or were we glimpsing something beyond our models, beyond our imagination? Some philosophers of science began to weigh in, gently reframing the debate. Perhaps the question wasn't what 3I Atlas was, but why it reached us. In a galaxy of countless silent objects, why this one? Why now? They spoke of cosmic perspective, of how a single wandering fragment can reflect the state of our own understanding. That sometimes, what we see out there is a mirror of what we hope, or fear, to find. The public grew more curious, but not fearful. There was a strange peace in the mystery, a collective pause as if humanity had agreed for once to simply listen. Listen to the silence between the data, to the story unfolding beyond the reach of proof. Back in the control centers, the scientists continued their work. They refined models, tested hypotheses, measured every flicker, every particle, every whisper of gas. But none of it changed the feeling that had begun to grow among them, that something about this object defied simple categorization. Not alien, not divine, not impossible, just different. Something that belonged to the quiet spaces between definitions. As 3I Atlas drifted farther from Mars, fading once again into the black, the debate subsided into silence. No conclusion had been reached. No theory could claim victory. It remained a puzzle suspended in the void, half science, half poetry. And perhaps that was the lesson it carried across the stars, that not every question is meant to be solved. Some exist only to remind us how little we know and how vast the unknown still is. As the object slipped deeper into the sun's light, one final thought lingered, soft, unresolved, yet endlessly compelling. If 3I Atlas is just a comet, then why does it move like it remembers something? 3I Atlas had passed Mars, yet its journey was far from over. The path it traced through the void carried it inexorably toward the sun, a slow, silent descent into light and heat that promised to reveal secrets hidden in shadow. The trajectory was precise, a hyperbolic curve that defied the familiar orbits of the planets and comets that called our solar system home. With every kilometer it traveled, the forces of the sun began to assert themselves, subtle, relentless, and transformative. From Earth and orbiting observatories, scientists began recalculating predictions. Solar radiation pressure would intensify. The coma might expand. Jets of vapor could erupt with new intensity. Every parameter had to be considered, not just the heat, but the tidal forces, the particle wind, the light streaming from the sun in every wavelength. It was a delicate balance, the choreography of physics playing out on a stage millions of kilometers wide. As the object approached, its glow shifted. What had once been a faint green luminescence now deepened, pulsing against the black canvas of space. Spectrometers detected the subtle excitation of molecules in the coma, light bending and scattering in ways that hinted at complexity, at layering, at structure beyond mere ice and dust. Even the faintest trace of water vapor seemed more vibrant in the sun's rays, each molecule catching light like a prism, scattering into an endless spectrum. The sun itself, normally so familiar, became a looming presence, not a threat, but a character in this silent cosmic drama. Its surface churned with flares and prominences, sending waves of charged particles outward. 3I Atlas would encounter this environment, and what had been a slow, steady drift would soon become an interaction, a dialogue between a wandering visitor and a star that had watched it approach across unimaginable distances. For a moment, space itself felt alive. Scientists anticipated these moments with quiet intensity. Observations from multiple instruments were scheduled: ultraviolet, infrared, radio, and optical. Every spectral line, every shift in brightness could reveal something previously hidden. Was the outgassing simply solar-driven now, or did some internal mechanism respond in ways unknown to human physics? The possibilities teetered between mundane and extraordinary. Cinematic images captured the object's passage, the faint tail stretching longer, hints of structure within the nucleus becoming more discernible, and the green glow intensifying as if awakened by the sun's proximity. Even the dust and gas emitted seemed to arrange in patterns, filaments, ripples, and arcs that defied simple random dispersion. Some scientists noted the uncanny resemblance to behavior usually associated with engineered probes, though they spoke softly, aware of the line between data and imagination. Closer and closer it moved, the solar influence unmistakable. Radiation pressure began shaping the coma asymmetrically, pushing vapor and dust along predictable paths. Yet small anomalies persisted. The object resisted some expected shifts, rotated differently than models suggested, and shed material in irregular bursts. It was as though the sun's pull was only part of the story, the dominant force met by something else, subtle and unseen. As the days passed, instruments captured spectra, showing new compounds becoming active. Particles in the coma glowed in ways previously unseen, reflecting energies the sun had not yet imparted. The interplay between solar radiation and the object's composition was creating ephemeral displays, transient phenomena that could vanish as quickly as they appeared. It was science unfolding like theater, precise yet enigmatic. From mission control, the teams worked in a rhythm dictated by data flow. Updates arrived in streams of numbers, graphs, and images, each more revealing than the last. And yet, despite all the measurements, the true nature of 3I Atlas remained concealed. Every revelation brought new questions. Every observation hinted at purpose, or at least at design beyond ordinary physics. The closer the comet drew to the sun, the more the tension of anticipation grew. Not in alarm, but in the patient, measured curiosity that comes with witnessing something unprecedented. Would it fragment under the heat, or would it respond with further activity unseen in any comet before? Would the green glow intensify, revealing new details of its structure, or fade, leaving only shadow? And so, it continued its silent approach, a solitary traveler meeting the radiance of a star it had never encountered before. The solar wind pushed, the light streamed, the nucleus glimmered, and 3I Atlas drifted closer to perihelion, carrying its secrets onward. For the observers on Earth and around Mars, there was no panic, no rush, only the quiet tension of anticipation, the delicate suspense of watching an ancient interstellar visitor draw near to the sun, and the knowledge that what came next could challenge everything we thought we knew about the cosmos. Despite the wealth of data streaming in from orbiters, spectrometers, and telescopes, 3I Atlas remained an enigma. Every measurement offered clarity and contradiction in equal measure. We could calculate its speed, trace its trajectory, and measure the composition of its outgassing. Yet the deeper questions persisted, silently mocking our assumptions. How could an object behave in ways that defied all known models of cometary physics? And what did that reveal about the limits of our understanding? Space, in its vastness, has a way of exposing the gaps in human knowledge. We pride ourselves on precision. Telescopes measure light from billions of kilometers away. Instruments detect single particles in the void. Computers calculate trajectories to millimeter accuracy. Yet, when faced with 3I Atlas, all of that expertise felt simultaneously sufficient and inadequate. The object moved not just through space, but through the boundaries of what we thought possible. Scientists debated the anomalies in small rooms filled with blinking monitors and soft hums of cooling systems. One moment, a reading confirmed the presence of water. The next, the vapor's behavior suggested energy inputs that could not be accounted for. Its rotation, the alignment of its jets, the pulsing green glow, all contradicted conventional models, and while each hypothesis seemed plausible in isolation, none could fully explain the object as a whole. In this uncertainty, wonder quietly took hold. The gaps in our knowledge were not failures, but invitations, a chance to glimpse the universe in its raw, unfiltered complexity. Atlas was both a puzzle and a mirror, reflecting back not just its own mystery, but our desire to understand, to categorize, to know. And yet, the reflection reminded us how small and limited we remain. From Mars, the faint glimmers of its vapor and light offered only hints. No probe, no lens, no instrument could capture it entirely. Every observation was filtered, partial, a shadow of the true object. We measured what we could, inferred what we could not, and yet, for every answer gained, two more questions emerged. The interstellar origin of 3I Atlas added another layer of complexity. It had traveled untold light years untouched by human eyes, carrying with it a history we could only speculate about. Where did it come from? What forces had shaped it before it entered our solar system? What secrets were embedded in its ice, dust, and subtle luminescence that no spectrum or image could fully reveal? Instruments aboard Earth-orbiting telescopes and Martian satellites continued to capture spectra, velocities, and emissions, but always incompletely. The universe seemed determined to remind us that observation alone cannot confer understanding. There were depths in its motion, in its composition, in its very existence that would remain hidden, waiting for tools, knowledge, or perspective we had yet to develop. This gap between observation and comprehension carried its own quiet poetry. It was in the pauses between data points, in the moments when models failed, that the cosmos whispered most clearly. It suggested that the universe is not meant to be fully tamed by equations or explained in a single theory, but to be approached with patience, humility, and awe. The green glow, the arcs of vapor, the subtle geometric hints in its nucleus, all remained open mysteries, and while scientists worked tirelessly, simulating conditions and testing hypotheses, a broader question hovered above all calculations. What does it mean when the universe hands us a visitor we can measure, but not fully understand? As 3i Atlas continued its journey, slipping deeper into the sunlight and farther from Mars, that question remained unanswered. It was an invitation, not an inconvenience. A reminder that in the cosmos, certainty is fleeting and discovery is endless. The interstellar object had become more than data points and spectral lines. It had become a symbol of human curiosity, of how, when faced with the unknown, we listen, observe, calculate, and imagine. And in the quiet that followed each observation, the cosmos seemed to wait, patient for our next attempt to understand. Even as it receded into the void, one lingering thought persisted. How many truths, invisible and unfathomable, travel silently across the galaxy, waiting for us to notice? The images arrived slowly, transmitted across millions of kilometers, each one a frozen moment of a traveler from another star. At first, they appeared simple, a bright, glowing nucleus wrapped in the familiar haze of a coma, a tail stretching faintly into the void. Yet the more the scientists studied, the more complexity emerged. Dust streams twisted and curved as if caught in invisible currents, forming arcs and wisps that danced gently against the blackness. The coma was not uniform. Light and shadow shifted across it, revealing pockets of density and regions of faint translucence. In high-resolution frames, the nucleus revealed subtle texture, mottled surfaces, sharp ridges, and depressions that caught sunlight in patterns impossible to ignore. It was neither smooth nor entirely irregular. Edges flickered in the orbital images, casting tiny ephemeral shadows across the surrounding mist. Each new frame seemed to hint at hidden structures beneath the surface, yet always withheld complete clarity, like a painting partially obscured by fog. The dust itself was alive with motion. Thin jets erupted in arcs, diverging and converging in patterns that suggested internal dynamics, forces unseen, but precisely orchestrated. Particles glimmered in sunlight, reflecting green and silver hues, faint but persistent, like strands of light caught in a cosmic wind. The tail stretched in multiple directions, twisting against the solar wind, revealing vortices and wakes that scientists could trace but not fully explain. Color filters and spectral overlays revealed more. Areas that appeared uniform to the naked eye displayed variations in chemical composition. Regions richer in water ice, pockets of carbon compounds, and hints of metallic elements scattered across the nucleus. These variations were subtle, yet consistent, suggesting a level of internal differentiation unusual for a simple comet. It was as if the object carried a complex history written into its very matter, each layer a page of an ancient, untold story. The images captured moments of imperceptible change. Over hours, faint bright spots appeared, then faded. Plumes of gas swirled, shifting direction in ways that defied simple solar interaction. The object was dynamic, alive in motion, yet measured, deliberate in behavior. Nothing about it suggested randomness, yet nothing could confirm intention. The coma itself was almost hypnotic. Clouds of dust and vapor spiraled in delicate eddies, catching sunlight at just the right angle to create halos, arcs, and shimmering reflections. The green glow observed earlier persisted, faintly coloring the edges of the coma, as though the object carried an inner light, diffusing outward through the haze. It was mesmerizing, unsettling, and entirely alien. Even the faint tail offered mysteries. Rather than a uniform stream, it split into multiple strands, curving and twisting, forming structures that suggested rotation or perhaps internal jets unseen in the core. The sunlight revealed subtle layering, filaments of dust that curved in concert with invisible forces, almost as if following a hidden blueprint. Scientists called them anomalous dust filaments, but to observers they were silent, glowing threads in the black tapestry of space. Zooming in on the nucleus, the smallest features became visible. Tiny pits, craters, and linear depressions suggested activity over millennia. Ice sublimating, dust shifting, jets carving away material. Yet some lines and ridges appeared too straight, too consistent, as though shaped by more than natural erosion. A human mind, looking at the images, could not help but sense intention, even in the absence of evidence. The interaction of sunlight with the object created fleeting optical effects. Glints and flares flickered across the surface, illuminating facets for mere seconds before fading into shadow. In some frames, the reflection of solar particles off dust clouds created tiny rainbows, subtle hints of color in a world otherwise dominated by black and gray. These ephemeral details suggested beauty and mystery in equal measure. With every pass of the orbiters, new angles revealed nuances previously unseen. The coma shifted with rotation, the nucleus showed new depressions, and dust patterns evolved as the object moved closer to the sun. Each image was a layer in a story, a cinematic unfolding of a journey no human had witnessed before. And yet, despite the clarity, despite the high resolution and the wealth of data, the object continued to conceal its secrets. Every ridge, every dust filament, every subtle glow suggested more than could be proven. Something about its core, its structure, its very presence remained hidden, teasing the limits of observation. As the final sequence of images streamed in, the quiet tension lingered. What lay beneath the mist? The dust, the subtle green glow. Was it simply an unusual comet, shaped by forces we did not fully understand? Or did these images hint at something deeper, something waiting to be discovered, a secret carried across the stars, silently, into our solar system? Studying 3I Atlas offered more than a glimpse of a single wandering object. It opened a window into the broader universe, inviting us to reconsider everything we thought we knew about interstellar travel, cosmic formation, and the history of planetary systems. Each observation, each spectrum, each image carried clues about the forces that shape not just comets, but the very architecture of galaxies. By understanding its composition and trajectory, scientists could piece together a narrative of where it came from, and by extension, the environments of distant stars and planetary nurseries it had passed along the way. The presence of water, the unusual chemical signatures, the patterns of dust and gas, all hinted at processes that might mirror those in our own early solar system. Perhaps in its frozen core were preserved records of planetary formation, locked away for millions or even billions of years, waiting to tell the story of worlds we have yet to discover. Each molecule, each particle of dust became a messenger from afar, carrying information about temperature, radiation, and chemical interactions across the vast gulf of space. By examining anomalies in its outgassing and rotation, scientists could refine models of how interstellar objects behave when they enter a new solar system. Were these behaviors common among all visitors from the void? Or was 3I Atlas unique, a rare example of an object shaped by forces we have not yet understood? Its study could reveal patterns in cosmic chemistry, shedding light on the processes that might seed life or influence the evolution of planets in distant star systems. The implications extended beyond physics and chemistry. There was an element of cosmic perspective, a reminder of our place in the universe. As we measured its journey, calculated its speed, and predicted its future path, we were also contemplating the vast distances between stars, the rarity of interstellar encounters, and the fragile window through which we had been allowed to witness it. It was a lesson in both humility and curiosity, demonstrating how a single object could inspire reflection on scales both immense and intimate. Further study of 3I Atlas could illuminate the diversity of matter traveling between stars. Each interstellar object might carry unique chemical fingerprints, telling a story of its home system, the temperature ranges, the types of dust grains, the history of collisions and formations that created it. By comparing these observations with those of comets and asteroids in our own solar system, scientists could map the similarities and differences, revealing common threads of planetary evolution, or startling deviations that challenge existing theories. There was also the tantalizing question of dynamics. Why had it followed this precise hyperbolic path? Did interstellar objects frequently pass through systems like ours, unnoticed, leaving behind traces we are only now beginning to detect? Each encounter expands our understanding of gravitational interactions and the invisible architecture of the galaxy, providing a natural laboratory to test the boundaries of celestial mechanics. Yet perhaps the most profound implication was philosophical. 3I Atlas reminded us that knowledge is never complete. Each discovery invites more questions than it answers. The very act of observing it forces us to confront the unknown and to acknowledge the vastness of what we have yet to comprehend. Its journey is a bridge between the distant past of other star systems and the curiosity of humanity today, a reminder that science is as much about asking questions as it is about finding answers. As researchers continued to analyze every detail, the object itself became a symbol, a catalyst for imagination, exploration, and reflection. It encouraged interdisciplinary thought, blending astrophysics, chemistry, planetary science, and philosophy into a single pursuit, understanding what lies beyond the borders of our immediate experience. And as 3I Atlas receded, slipping farther from Mars and closer to the Sun, one quiet question lingered in every mind observing it. What other secrets, hidden in the dark reaches between stars, await discovery, waiting for humanity to notice and unravel their mysteries? Atlas began its final leg through the inner solar system, moving steadily along a hyperbolic trajectory that would carry it far beyond the influence of our planets. Its journey was a reminder of motion on a scale almost impossible to grasp, an object traveling at tens of kilometers per second, bridging the gulf between stars untouched by human hands yet observed with careful precision from Earth and orbiting instruments. Distance became a living dimension, every kilometer adding layers to the perspective of the universe's vastness, every calculation a small testament to human curiosity. As it moved outward, the sun's influence gradually waned. The intense radiation and solar winds that had sculpted its coma and tail now diminished, allowing the object to drift in a quieter environment, the subtle forces of gravity from distant stars becoming more significant than anything in our solar neighborhood. The green luminescence, once so vivid under solar illumination, softened and spread, fading into a gentle shimmer that hinted at composition, chemistry, and history, rather than immediate activity. Dust streams and gas jets slowed, curling outward into the emptiness, leaving behind a fragile trace of its passage. In this quiet retreat, the scale of 3I Atlas's journey became humbling. It was a lone traveler, moving through space that had been unchanged for eons, where distances between objects are measured in light years and time stretches into millions of human lifespans. Yet, despite the emptiness, there was movement, and in that motion, a story of origin, of cosmic history, and perhaps of a path deliberately traced long before humanity could look up and wonder. Each observation of its position, rotation, and residual activity was a small bridge between our world and the vast reaches it would never touch again. Scientists reflected on the unique opportunity its passage provided. Few interstellar objects enter our solar system in ways that allow such detailed study. With each measurement, each spectral analysis, each image of its fading glow, we gain insight into the composition and dynamics of distant star systems. Its icy core, dust-laden tail, and subtle emissions offer clues to processes that shaped planets, comets, and debris across galaxies. The data collected becomes a proxy, a silent archive of environments and histories that no telescope could otherwise reach. And yet, even with this knowledge, much remained unknown. How had it survived the interstellar journey intact? What forces shaped its trajectory before it encountered our sun? How representative was it of the countless other interstellar wanderers drifting unseen across the galaxy? Each answer unearthed deeper questions, emphasizing both the power and the limitation of human observation. The perspective shifted as the object left the planetary sphere. Mars, Earth, Jupiter, and the outer planets receded into points of light, their influence on 3I Atlas negligible compared to the immensity of interstellar space. Gravity wells of other stars, cosmic dust clouds, and dark, empty voids would define the remainder of its path. Its motion, though predictable in terms of physics, carried an aura of the unknowable, a journey that began in a distant system, whose details were forever out of reach and now moving toward the infinite unknown. As it traveled, the sense of awe deepened. Observers considered the timescales involved, the billions of years it may have spent wandering the Milky Way, the light years crossed before ever brushing against our sun's warmth. The silence endured across the void. Compared to human lifespans and even the age of civilizations, its voyage was both incomprehensibly long and fleeting in the observer's eye. a reminder of the temporal scales of the cosmos. The fading green glow and dissipating dust trails carried the memory of the journey, a faint signature in the fabric of the solar system. Each passing day, the object moved beyond the reach of routine observation, yet the imprint of its presence lingered, in data, in images, and in the minds of those who watched and wondered. It was a fleeting visitor, yet one that left an enduring mark on our understanding of the universe. In leaving the solar system, 3I Atlas became a symbol of motion, of distance, and of perspective. It reminded us of the galaxy's vastness and our own smallness, and yet, paradoxically, of the capacity of human curiosity to reach across that expanse, to touch the edges of understanding, even if only briefly. As the object disappeared into the dark between stars, carrying its secrets far from our reach, one thought lingered, haunting, reflective, and profound. What other mysteries drift silently through interstellar space, waiting for a future observer to glimpse them, to measure them, and to marvel at their presence long after we are gone? Even as 3I Atlas vanished into the vastness beyond our solar system, the universe remained, vast, patient, and indifferent to our brief moment of observation. Its silence was not empty, but full of motion, of energy, of countless objects moving in patterns and paths that we had yet to perceive. Each star, each comet, each drifting fragment of ice and rock carried stories older than human memory, histories written in the language of gravity, light, and time. And as we watched, measured, and recorded, we were reminded of our place, small, curious, and fleeting, yet capable of glimpsing the extraordinary. The passage of 3I Atlas had stirred more than scientific inquiry. It had awakened a sense of wonder. Across observatories, research papers, and quiet reflections, the object had invited humanity to consider what lies beyond the familiar, beyond the comfortable models and explanations. The green glow, the subtle structure, the unexpected jets of gas, all were markers of the unknown, gentle provocations that coaxed us to expand our imagination alongside our knowledge. To look at a distant visitor and see not just ice and dust, but the possibilities of what might exist beyond the boundaries of our experience. Humility came hand in hand with curiosity. We measure, we analyze, we theorize, and yet the universe reminded us how little we truly know. For every discovery, there were countless more hidden in shadow. Every image brought clarity, yet also revealed the depth of the questions still unanswered. 3I Atlas was a mirror, reflecting both our thirst for understanding and the limits imposed by time, distance, and perspective. Across the spectrum of human thought, from astrophysicists calculating trajectories to philosophers pondering cosmic significance, one idea resonated. The universe does not rush to reveal its secrets. Its wonders unfold slowly, often without notice, in ways that challenge our assumptions and invite reflection. Observation is only the beginning. The true reward lies in contemplation, in connecting what we see to what we imagine, and in embracing the vast unknown with patience and awe. There is a quiet rhythm to this process, a cadence that mirrors the movement of the cosmos itself. Stars are born, planets form, comets drift, and civilizations arise, all against a backdrop of immense timescales that dwarf human existence. In that rhythm, 3I Atlas's journey became a fleeting but vivid pulse, a momentary bridge between interstellar emptiness and human attention. We glimpsed a fragment of the infinite, and in doing so, we experienced both wonder and responsibility. The awareness that observation shapes understanding, and that our curiosity must remain vigilant, respectful, and open. The object's departure leaves us with questions that cannot yet be answered. What other interstellar travelers await our discovery? What stories do they carry from distant systems, and how might they reshape our knowledge of the cosmos? Could some hold chemical secrets, clues to planetary formation, or even hints at conditions that nurture life beyond our solar system? Each of these possibilities lingers in the mind, quietly without demand, a whisper from the universe that encourages us to keep looking, to keep learning, to keep imagining. Even as instruments cease tracking, even as the green glow fades into memory, the experience lingers. It reminds us of the delicate balance between observation and interpretation, between fact and imagination. It shows how curiosity, when guided by patience and humility, can bridge the vast scales of space and time. It demonstrates that the act of watching, of attending to the universe's quiet signals, is itself a form of participation in the cosmic narrative. Humanity's relationship with the unknown is, in essence, a conversation. Sometimes the universe speaks in sudden, startling ways, like the unexpected passage of an interstellar object. Sometimes it whispers through subtle patterns, gradients of light, or shifts in a star's behavior. And sometimes it simply waits, allowing us to arrive at our own understanding, at our own readiness to perceive and interpret. In each instance, our role is the same: to observe, to reflect, and to wonder. Three-Eye Atlas has gone, but the universe remains vast, intricate, and full of silent motion. The objects yet to be discovered, the phenomena yet to be understood, are countless. Each holds the potential to teach, to inspire, and to challenge our assumptions about reality. And in that ongoing, patient expanse, humanity finds both its humility and its hope, that through curiosity, persistence, and contemplation, we may continue to encounter the extraordinary again and again. As the cosmos stretches endlessly beyond comprehension, one quiet truth remains: the universe waits. It waits for observation, for discovery, for reflection, and for imagination. And when we are ready, it will reveal fragments of its infinite story, in ways subtle or profound, guiding us toward ever greater understanding and awe.